what if the internet could actually think before answering you? I mean, not just matching keywords, but understanding what you truly mean. Today, we're going to unlock one of the biggest secrets behind modern AI.
You search for something simple. Maybe you're looking up apple orchards. And boom, you're getting results for the latest iPhone. It's so frustrating. This simple confusion, though, it actually points to a really deep problem with how computers have traditionally understood our world.
So this is our journey for today.
Okay, let's dive right in. The root of this whole Apple problem lies with our old, trusted databases. Now, for decades, they've been the absolute backbone of business, but they have a critical weakness when it comes to understanding meaning.
Think of a standard SQL database like a brilliant but very rigid accountant. It's perfect for numbers, tables, structured data. But the moment you give it a picture, a song, or even just a paragraph of text, it gets completely lost. To the database, all this rich data, this unstructured data, was just a blob. A digital box it could store, but never, ever understand what's inside.
So how do we teach a machine to understand? The answer came with a new kind of data type, one that honestly comes with a genuine superpower. I am talking, of course, about the vector.
Now, at first glance, a vector is just a list of numbers. But, and this is the key, these are not random numbers. They are a mathematical fingerprint of meaning. They capture the context, the relationships, basically the very essence of a word, an image, or even a sound. And this is what shows the magic. Just look at this equation. When this was first discovered, it was absolutely jaw-dropping. We can now perform mathematics on concepts. The vector for king minus the vector for man plus the vector for woman gives us a brand new vector that is incredibly close to the vector for queen. We are literally doing math on meaning itself.
So you have to be asking, right? How is this magic even possible? How do we create these powerful vectors from simple words or pictures? The answer lies in a process called embedding.
Embedding is this amazing process where an AI model takes a piece of data, like our word apple, and it maps it into this huge multi-dimensional vector space. And the truly clever part is that it preserves context, so words with similar meanings get mapped to vectors that are close to each other in this space.
Now, the word embedding can be a little confusing because we use it in two ways. So think of it like a painter. The process of painting is the action, the verb. The result of that process is a noun, a painting. It's the same thing here. The process of embedding, the verb, creates an embedding, the noun, which is the vector itself.
Okay, so we've got this fantastic new data type that actually understands meaning. But what happens when we try to put this new wine into old bottles? What happens when our traditional databases, our old trusted accountants, try to manage this new kind of AI-powered data?
Well, this brings us to a fundamental clash. You can think of it as a battle between the old world of structured data and the new world of semantic meaning.
See, on one side you have SQL databases. They're built for accounting math, exact matches, keyword searches. They just are not designed for finding things that are similar. On the other side, you have vector databases. These are built from the ground up for AI. They use specialized indexes and native operations to find things that are semantically similar, not just textually identical.
Now, you might be asking, hey, what about NoSQL databases? And yeah, it's true, many of them have added vector features, but it's important to remember that these are often a retrofit. They weren't born for this job. And when you get to really large-scale applications, a specialized native solution is almost always going to perform better.
In the real world, though, it's rarely a case of just one or the other. The true power, the real magic, often comes from combining them. We need the best of both worlds.
Just think about it for a second. An image vector can tell you that a photo is similar to another photo of a sunset. Fantastic. But you also need the traditional stuff, the metadata. What's the file name? When was it taken? What camera was used? You need both the meaning and the facts. And this is what a hybrid query looks like. We're telling the database, find the top 10 vectors most similar to my query, but only show me the ones where the metadata category is science and they were published after the start of 2023. This combination of semantic search and structured filtering, it's incredibly powerful.
So where is all this technology actually changing our lives? The truth is, you're already using it every single day, probably without even realizing it.
Every time Google just gets what you mean, even if you typed it a bit wrong, that's semantic search. When Flipkart or Myntra recommend a product you might actually like, that's a vector-powered recommendation system.
From intelligent chatbots to image retrieval to fraud detection and even to discovering new medicines, this technology is absolutely everywhere. And now, let's look back at our map. Do you see it now? Each part isn't separate. It's a chain that makes the whole system come alive. We started with the problem of unstructured data. We used the magic of embedding to create meaningful vectors. We stored them in a specialized vector database. And finally, we unlocked the power of true semantic search.
So, we've seen the incredible results. But this leaves us with one final and really profound question. How does a machine, which is just a collection of circuits and code, how does it actually learn the subtle human concept of what a king is or what a queen means? How does it build that mathematical fingerprint of meaning from scratch? That is the incredible story we will uncover in our next explainer. Hotty hot,